So they never, I mean, they are just, as a country, they are very, very good enough of maintaining the ecosystem. That is why, whatever they are saying, it is really, you know, I mean, they will be able to predict. But in Indian continent, the problem is we have already, spoil a lot of things, a lot of ecosystem, right? And how do we predict? I mean, that is also one of the reasons. I mean, we can't say it is 100%. I have given you a first answer. So it is not that every time we blame each and every one, but every a citizen of India, we have the responsibility, and we had also spoiled our environment. And that is why most of the time we couldn't predict the right value. The other thing, predicting the test results. You can also change the age range. Also change age. You can also change person. You have to get yes. Even if you do the exact value, it will just predict as per the model.
We are giving outside
Now
the
close
range.
to. Now this person is likely to buy the product.
Hello.
Sendil, you're on mute.
Okay. Okay. So I'm just adding the outside range. So this is a maximum 1,50,000 is the value range maximum. So we are putting 1,000 extra, but still based on that train on 150, then it's just trying to extrapolate, right? So maximum range age is actually 60. So it can predict up to 60 years of age, right?
Yes.
So if I go with the 61, see, for example, if I say make
change, yeah.
If I go with the 61, If I go to 61 and value, I'm just putting 1,51,000. So it is there actually, it is getting value of 1,51,000. Yeah, it's staying its one value.
Likely to spend or likely to purchase.
Yeah.
Satil, go to age 61 and see what is the salary there.
Age?
61.
No, we don't have that.
No, don't. It's outside range now. See, for
Oh, you are
example,
giving outside the range. Okay.
outside the range, I'm trying to test. So it trained on 1,50,000 data. It is trains one value. For example, where is that?
1,50,000, you have one value which is 32.
1,50,000 has two values: 32 years of age, 52 years of age. Purchased is trained on one. So when you are putting 1,51,000, so it is using this thing as a purchased one and predict the value as one. That's the reason it is getting value 1. Even if you put extra value, for example, I'm putting some 75 years of age.
And increase the value.
Okay, and I'm putting to some 2 lakhs.
This is the salary of
2,000, 20,000, 2 lakhs. Okay. If I predict, so let's see what is the value. Still, it is getting 1. So
See,
all the value.
The age calculation, you open this thing, data set, remove. Why it is showing 1, I will tell. Come down. It's a mixed age. Okay. So if you see anything above 40, there are people not less than.
Let me filter this.
One hour. So see here, age 44. How many are there with 1,50,000 at least, like above 1 lakh?
Okay,
There are more.
Yeah, they have more than 1 lakh.
These are all above 1 lakh.
Mm.
That is why you get 1. Majority.
Mm.
You see the age range there on the left side.
Mm.
Everything
See the range.
is 32.
If you take the range, to minimum is 27, maximum is 60. Till 60, yeah, they have value, a majority of data points. If above 1 lakh salary, so that comes under the purchasing ability.
Yeah. So if you see age range less than 27, the salaries will not be more than 1 lakh. If you subset that way. Remove purchased, also unfilter the purchased also. Yeah. Now less than 27 you select. Hmm. You see the packages come down.
All are zero, not
All
purchased.
and see
And
all
the
the
values estimated salary also less than lakh.
less than 1 lakh.
One
So
one guy is having 1,18,000, but still he is
but
comes under okay.
that
Mm,
is okay. But if you see the values like less than 1 lakh, even uh, above 1 lakh only one. So above 1 lakh and less than 1 lakh, the number of data,
mm,
if you see, less than 1 lakh is more.
mm,
So that is why it is not predicting for people who are less than 27 of age.
mm.
And then if you go to the other way
No,
around,
it is
above
predicting
27 also.
it is
No,
predicting the value. Mm,
no, no, no. It is not predicting the age. It is predicting the age based on the salary because your uh, your age range is 60 or 75. Correct. So if you
mm,
see only above 30, people with the age above 30 are having 1 lakh plus salaries.
mm,
And
mm,
if you again see in that also, people who have 1.5 lakh salaries are above 40.
mm.
Subset that way, subset above 35. From 30, you have subset. Hmm. Okay, now you see uh, purchased, you subset to purchased. So here, estimated salaries, you remove all below 1 lakh.
This is above 1 lakh.
Now you see the age range. Minimum is 32. No, no, no. Don't subset. You just see here. Minimum is 32, maximum is 60 because the data is only till 60.
Mm,
Maximum is 60. So,
60. Mm,
yeah, in this also, if you see uh, estimator, salary estimator, if you go, uh, select only people with 150 and above. Estimate.
only
Two people are there. So That is why if the age is increasing, at least one person will be there who will be having the salary range and will be a potential purchaser. That is why when you put 70 or 75, it is giving you 1.
Any range like see, for example, 62 is any range I'm giving, it is taken as 1 only.
1,
Because
yeah.
because it is assumed that it is get trained like based on the data. See, for example, I'm putting 65. Okay. So the salary, if I put not 1 lakh, 90,000 I'm putting. Okay. Let's see.
It will still give 1. You give 10,000 also, it will give 1. $10,000, yes. It will give 1. So any value, yeah. So this is again a different rationale. Any value outside of the range, if you give, it will be 1.
Yeah, that is actually that's what they're saying. The model, it won't give the correct extra, the predict the value if it is beyond the range.
Yes. So yeah, out of the range values, theory is doing itself, but we should not depend or rely on the information which is out of the range, even though data is trained.
Correct. Trained is within the range always.
Yes.
That's a problem. But they are saying like here, outside range value, they're saying random forest can be helpful. Random forest being based on the decision trees will still give you a prediction for values outside of the training range. So the random forest, they're saying that it gives the prediction, but
Prediction, no. It is giving the prediction, but it is not accurate.
Correct.
That is what we just checked.
Yeah. Yeah, we are using random forest only. See, this is a random forest only, right? So we are using the random forest, but still the prediction is not accurate. Yeah,
Not
I
accurate.
agree with that.
So if you give 1,50,000 also, it is giving you 1 result. If you
One
give
only.
10,000 salary with 68 days also, it is giving result. But all the result is same. Result is not changing. That you see? Yeah. We changed the salary, we changed the age range, many things we changed, but still the result is same. Now it changed.
Because it's below the value, right? It's a completely trained data. So anything within the scale range, it can able to predict.
Yes.
Because it is already trained. So they know the prediction, like below the some 35 years of age as a less salary. So that actually predict not the purchase
Maybe
demand.
try with the 15 years.
50?
15, 1.5.
1.5, okay.
1.5 is again out of the range.
Let us see.
It will give 0.
0.
Yeah.
Oh, below and maximum, you mean to say, like, okay,
Yeah,
even above and below. Okay.
So it has only 2 prediction values. Out of the
Correct.
range, if you increase the age, it will give 1. If you decrease the age, it will give 0. Probability.
So I think your mind is getting tuned to the mission, and it is the right time to start the next algorithm. So tomorrow we'll be starting the clustering techniques, and also we'll go with the other models.
So this is fine, Sini. I think the confusion matrix and accuracy score.
Yeah.
So this is the similar kind of, and trying to
Exactly.
visualize the results. Yeah, this is just trying to visualize that
Yeah.
forest model. Forest
Even you
graph.
can try to change the visualization methodology. So any kind of a graph you want to
But
change.
one thing I noticed is, like I
Mm,
changed kind of values.
mm,
Like earlier, the values were different.
mm,
Here in this, like Senthil changed. I gave age 47 and salary as 25. It is still predicting. And test results I have taken. And then confusion metrics. No
mm,
matter what age I'm changing, what the salary I'm changing,
mm,
confusion metrics output is not changing.
mm. Yeah,
So,
it has its own reason because how you are taking the value, how you are taking the training and test results, X test and Y test, and what would be the prediction. And based on that, I mean, you just closely observe. Okay, so which parameter you have changed, and then according to that, whatever what you are see, confusion matrix is always for the validation purpose. Whether you are going in the good direction with the same model, you are validating. We are validating ourselves, right? So why we are going for confusion matrix? So that you have to think. So then you can make a see. We should not be see, that is one of the other challenges in machine learning. So one concept will be familiar, and then if we go for the other concept, we have to connect the dots. So now you have the analytical ability and the other abilities, and you found out some logic, it is working or it is not working. Now you are finding out some confusion matrix with relevant to, and you have to find out the relevancy and in which parameter you are going for the confusion matrix. So you have to give the right parameters and then test it, because confusion matrix will have the impact, but again it is based on you have to rerun everything. Okay. Just test it, and then we'll discuss tomorrow.
For example,
Uh,
yeah, if you see now, Senthil has changed the age range, like it is out of the range. If you go,
mm,
prediction is out of the range, 15 years of age and salary is 10,000, zero. But if you come down, confusion
mm.
matrix result is same
No,
as my result.
This
no.
is actually
Here the
we are just
yeah,
printing. That means we are testing the
we are
value. It's
printing
not we are
exactly.
changing the value.
You are
We are
changing
not
and
change any
printing.
value.
Yeah, exactly.
Oh,
Here we are not change any value. We are just testing here, just using the print statement. Okay, if I am change the value, what is the output of this? We are just
Exactly.
testing here.
We
probability you
never
are
change
testing.
anything.
We
You
are
have to
never change
change the
anything.
input. Yeah, you have to change the input. Okay,
Okay,
you have
okay,
to
okay.
change the input and change the format and everything, and then apply confusion matrix. If there is any difference and deviation, then you have to take a call. So here, we are just applying out of the range, and this kind of things never got trained before, and we wanted to see whether this model is working beyond the control. That is what our question is. Okay.
Hmm.
Right.
Okay, okay. Now I okay.
Yeah.
Hmm.
This is the what is that value?
Yeah.
Yeah, we're getting. Okay, okay, Sini. Yeah.
Okay. Good. Great. We'll
So
see.
this end actually what is that classification is done. Okay,
Yes. Yes.
like
Classification
with the
done.
random. Okay, tomorrow we are going with the clustering. Huh?
Clustering.
Clustering.
Clustering,
Okay.
very soon we go, and then we have to go with the rule association, association rule learning, and then
So
we have
all
to
these
start.
models follow the same process. Like if you follow the process, I think it's almost similar. Like train, we have to data set split and then feature scaling and then applying the model and then visualize the results and then go with the confusion accuracy score and then what is that final
Final output,
Process,
right?
visualization. So
See,
this is the
process.
process remains same. Mm.
process of basic machine learning looks similar to what we are doing right now, but
Oh,
there
okay.
are researchers, they will be getting the similar kind of an output without following this, but still training, testing, and everything, I mean, it should be similar, but deep learning is different.
Mhm.
training testing would be there, but the other processes and other things, will be the different process you'll be seeing. That is that field, you will get a different field. Very soon you will be getting. We'll be diving into that.
So we won't do any standard scaling like feature scaling. We don't
Nothing.
do that in that.
No,
Okay.
no. That is a different process over there.
Mm-hmm. So
Entirely
this is
different
just a
process.
machine. This is just a machine learning concepts. These are all
Yes.
machine learning algorithm.
Yeah.
Okay. That
When
the
it
feature
comes to deep,
pre-processing.
when it comes
Mhm.
to deep learning, we are mainly going to deal with neural network. In neural network, we'll be applying a similar kind of a concept, but with a different terminology, different process. The process is entirely, out of our imagination, and we have to change the entire thought process from basic machine learning to deep learning. So that process also, you have to be ready. Okay, so don't think that this could be the similar kind of an approach.
Mm.
It won't be, yeah, and it never be.
Oh,
That is
okay.
why it is a challenging environment.
Very challenging.
Yeah.
So many. No, remembering everything is like we have to create our database in our brain.
Yes, it's like, yeah. Now for analytical part, you are tuned to analyze the machine learning process now. That is why, I just kept quiet and you guys were discussing. It's really amazing, and you got into this. But the same kind of an analytical part you have to import and impart during the process of neural network. So when we start the artificial neural network, when we start the CNN, convolutional neural network, and recurrent neural network, there are so many neural network techniques out there, and that is going to be for one neural network. ANN is very easy, but see, right from the CNN, it is for one concept, it will take 2 classes or 3 classes. So yeah. Each and every word is very important. Every technique is very important. But the code is very, very simple, one-liner code. One line of code, but to understand it much better from our ability, we have to go through calculus. We have to do, but we don't want to go in depth for those kind of a mathematical challenges, but we should know how it performs and how it is just taken into consideration. We will discuss calculus, we will discuss integral calculus, algebra, all these things come into place when we are discussing neural network. That is the main, because we are going to develop or imitate how our brain works. So for those kind of things, we should have some calculations, and we have to do some kind of a rule-based learning, and that rule-based learning, it should relate to our processes. That is why I would say our life is in machine learning, and machine learning is it's a kind of a vice versa statement. That means whatever we are thinking, we are just writing it up. Whatever we are writing it up, we used to think. So let's see. Yes. Another kind of a statement. Okay, so let's enjoy this journey, so that you also. So you are going to do a project very soon. Let's see.
Okay, Sini. Okay.
Okay. Thank you so
So
much.
just to share the previous recording and today's recording, Sini. We will get
Sure. Okay.
last class.
Okay.
Okay. Thank you.
Thank you so much.
Yeah.
Thank you, sir.
Bye.